Welcome to Mastering Solutions. We don't need to draw a ray diagram in this question as we've done on a lot of the previous questions, but we do need to calculate the image position and the height. So let's start with the position, and we can use the thin lens equation for this. Even though we're dealing with a mirror, this thin lens equation still applies for it. And it says that the power of a lens or a mirror is equal to 1 over the focal length in meters. And then that's also equal to 1 over the image distance plus 1 over the object distance. So we're just going to take this section here, and we're trying to solve for the image position, of course. So let's minus over 1 over s. So 1 over s prime is equal to 1 over the focal length. And since we have a converging mirror, that will always have a positive focal length. And then we're going to minus 1 over the object distance. And since it's in front of the converging mirror, of course, that's how a mirror works, this will also be a positive value here. So 1 over s prime is equal to 1 over the focal length in meters is 0.25 meters, minus 1 over the object distance, also in meters, 0.45 meters. So 1 divided by 0.25 minus 1 divided by 0.45 gives us 1.78, and that's diopters, but we need it in meters. So a diopter, since it's an inverse meter, if we take the reciprocal, will give us meters. So if we move the decimal place twice, that gives us the image distance is equal to 56.25 centimeters. And so that's our answer for the image position, and it's positive, meaning that it's on the same side of the mirror as the object. If it was negative, that would be virtual, and it would be on the opposite side of the mirror as the object. So that's different from lenses. Now let's calculate the image height using magnification. So m is equal to h prime over h, or the image height over the object height, which is also equal to negative image distance over object distance. So just using this section to isolate the image height, which we want, we can multiply both sides by h. So now we have h prime is equal to h times a negative s prime over s. And so we have all these values, so we can plug them in. The object height is 3 centimeters tall. So we have 3 times 10 to the negative 2 meters. And then we're multiplying that by a negative. And this negative comes from the equation, but we don't have a negative here. So we have 0.5625 meters. So that one will be positive. And then the object distance we said was 0.45 meters. So here's 3 times 10 to the negative 2 times a negative 0.5625 divided by 0.45 gives us an image height of 0.0375 meters. So if we move it twice, we get a negative 3.75, and that is in centimeters. So this is the image distance and the image height. Our original image was 3 centimeters tall, so we got a little bit of magnification. And since this is positive and negative here, that means we have a real and an inverted since the image is negative. So we have a real image that is inverted.